Assalamualaikum and a very good morning. So today we'll look on the presentation on transmission electron microscopy, which is called as TEM. So first of all, I'll introduce my group members, which is consists of Nur Akila, Muhammad Sharif, Nur Atasha Fitri, Nur Shakira, and Yasmin Nurdiana. So before moving on to the presentation itself, we'll look at the overview. First of all, in this presentation, we'll cover the introduction. The second is sample preparation. We'll see how the sample is prepared and in what type of physical properties it should have. And thirdly is the procedure. The procedure is more to how we use the machine itself. And finally, the example of image produced and the data analysis as well. So for the introduction here, the transmission electron microscopy TEM use transmitted electron, which electron passing through the sample to create an image. It is used to determine the crystal structure, morphology, and de-spacing of the sample. Only can image a very small part of the sample. This is actually a very good, it's one of the advantage of TEM, where it has very high magnification, so that even a very small size of sample also can be determined. So this is the structure of the machine. The main part of the machine is the electron gun here. This is where the electrons are produced. And here specimen holder, here is the place where we insert our specimen or the sample. And finally, we'll look at the picture of our sample at the camera chamber over here. And then the sample preparation, the samples prepared should be very thin, which is almost lower than 150 nanometer. And the sample can be prepared either in powder or liquid form. If the sample is in powder form, the sample should be initially mixed with solution, which is consists of distilled water, acetate, or ethanol for the dispersion process in 15 minutes. Since it is a dispersion process, if we are using polar solvent, we have to use non-polar solution. And if we are using the non-polar sample, we have to use polar solvent so that the dispersion will be formed. And then the sample was dropped on the copper grid film, and finally the sample was dried and ready for the analysis. The main components of the TEM is an electron source, which is free emission Fe. It is 100 times better resolution than tungsten. And then a series of electromagnetic field and electrostatic lenses to control the shape and trajectory of the electron beam. And finally, the electron aperture. For the procedure, first of all, when we want to use this TEM, we have to form a sample first. So for the sample preparation, the sample can be in various forms, just like mentioned earlier, whether in powder or liquid. The sample will undergo the sample preparation procedure part first, as we have covered before this. And secondly is the specimen holder. Next, the sample will be filled into the specimen holder, and the holder was locked to ensure the sample will not fall off. The third one is chamber. The specimen holder was inserted into the instrument in the proper way and correct orientation. Then wait a few minutes to let the vacuum process before closing the instrument. The purpose of the vacuum is to get a very clear image on the fluorescent screen and to get a very concentrated electron at the particular area. And finally, the fluorescent screen, the electron will pass through the column cross section and the image of the sample was observed and the suitable sample. Interest region was selected based on the objectives of the experiment. So this one of the result here is how the software look like when we are using the TEM. And you all might be asking what is a black color stopper here. So it is called a beam stopper and it is used to prevent burn or damage to the camera caused by the direct powerful light beam due to high intensity. This probably because the camera is placed under the machine itself, where but the beam or the electron gun is at the top, so it will shoot directly at the camera and it can cause damage to the camera. And here we can see the D spacing to determine the sample material. The symmetrical of the ring observed, the distribution of electrons, which is the diffraction pattern based on types of samples. Based on the observation of the result, we can determine the shape, the type of sample, which are single or poly crystals, the spacing, locality, and the coordination of electron of the lattice structure. So the sample we have used is one of the master student sample, and he said it is a mixture of copper and ceramic, if I'm not mistaken. So I think that's all. Thank you for the presentation. And next we'll move on to the video on our experience, how was our experience using the TM at the IBS. So I think that's all for our presentation. Thank you.
Kita menunggu, sementara kita menunggu sampel kita ni masuk. So sikit introduction lah. So kita punya gun, elektron kita dekat atas, right? So dia ada elektron gun sini, right? So ini kita pakai 200 kV. So elektron akan pass through this column, right? So kita ada condenser aperture, kita ada objective aperture. So sampel kita masukkan kat sini, right? So nanti elektron akan transmit sampel. So elektron akan transmit sampel. So dia panggil transmission. Right, kita akan transmit sample and then dia akan appear dekat fluorescent screen. Right, so dekat sini kita boleh buat observation lah. Right, it's very simple. So electron transmit sample, then dia akan appear dekat fluorescent screen. Right, so kita akan observe kan. So sample kita dah masuk. Dan saya on beam. So kita akan nampak elektron, dan kita akan nampak sample kita. Okay. So ini samples lah. Oh, okay. This yang ni adalah kita punya lacy carbon. Hati-hati lacy carbon So dia macam spider, dia punya web lah. Right. So kita akan cari sampel yang suitable. Lepas tu nanti kita akan buat imaging lah. Sebab imaging dulu. So ini sampel kita. So kita boleh cari jalan lah. Boleh go around. Dan tengok mana yang kita rasa okay. For example, kalau kata this area okay kan? So this area okay, saya tengok kepada berapa magnification. Right, katakan ini ada 50,000 magnification. Right, so saya akan acquire. Okay, so ini kita dapat partikel kita. Okay, kalau kata okay, ini kita akan acquire. Right, so ini step yang pertama adalah for imaging. Right, for imaging, it depend lah berapa magnification dia nak buat. Right, so the second step, kalau katakan dia nak tengok on lattice structure atau atomic level. Kan? So kita kena increase sebagainya high magnification lah. Right, so saya akan increase magnification. So saya akan select only one particles lah. Katakan saya select this one. Right, saya select yang ni. So kalau kita sampel tu dia too thick, so kita takkan nampak dia punya lattice structure lah. Lattice structure bawa kepada crystallography tadi lah.